Assalamualaikum and good morning. I am Muhammad Amar Hanafi bin Jamalullah. I am from Group 5, Coulomb S Law. Today, I will present about introduction and a little bit of concept of review. Okay, the introduction of Coulomb S Law is the law of Coulomb, or the inverse square law of Coulomb is an experimental law of physics that quantifies the sum of force between two electrically charged stationary particles. The electrical force is conventionally called electrostatic force or Coulomb's force between charged bodies at rest. The French physicist Charles Augustin de Coulomb first discovered the rule in 1785, thus the name. The law of Coulomb was crucial to the growth of electromagnetism theory, perhaps even its starting point, as it made it possible in a rational way to address the sum of electric charge. The law notes that between two-point charge, the magnitude of the electrostatic force of attraction or repulsion is directly proportional to the product of the magnitude of the charge and inversely proportional to the square of the distance between the charge. The power join the two charges in a straight line. If the charges have the same symbol, the electrostatic force between them is repulsive. The force between them is appalling if they have different signs. The law, as an inverse square law, is similar to the inverse square law of universal gravitation of Isaac Newton, but gravitation force are often attractive, while electrostatic force can be attractive or repulsive. Next is concept of review. The concept of review is Coulomb's law defines that the magnitude of the force is linearly proportional to the net charge on each object and inversely proportional to the square of the distance between them. The force does not depend on the mass of the object. The direction of the force vector is along the imaginary line joining the two objects and is dictated by the sign of the charge involved.
My name is Gary, and I'm going to continue presenting for review of concept. As you can see, the electric force F on one of the charges is proportional to the magnitude of its own charge and the magnitude of the other charge, and is inversely proportional to the square of the distance between them. This is the formula. F is for electric force, Q1, Q2 is for the electric charges of the two objects, while R12 is the vector displacement from Q1 to Q2. Formula of repulsion. Coulomb's law gives the force of attraction or repulsion between two-point charges. If point Q1 and Q2 are separated by distance r, then magnitude of the force of attraction or repulsion between them is like in the formula. As you can see, this is the formula for repulsion. We have F equal to K, Q1, Q2, and R squared. K is the constant. This is constant. K equal to 1. For K equal to 1 over 4, 8.5419 by the power 10 of negative 12, C2 over an M squared. This is the full formula, the simpler formula. The magnitude of the electric force or Coulomb force between two electrically charged particles. Thank you.
Assalamualaikum and good morning. My name is Muhammad Ali Nazifuddin. I'm going to represent slide 9 to 12. So I'm going to talk about repulsive charge. Q1 and Q2 have the same sign, hence electric force is repulsive. Attractive charge Q1 and Q2 have opposite signs, hence electric force is attractive. Background of the theory. Ancient cultures round the Mediterranean knew that bound objects like rods of amber might be rubbed with cat's fur to draw in lightweight objects like feathers and papers. Around 600 before century, tales of Miletus created the primary recorded description of electricity once he noticed that friction might render a chunk of amber magnetic. (16th century), William Gilbert created a study of electricity and magnetism. Characteristic: the static magnet result from electricity made by rubbing amber. He coined the new Latin word electricus from the Greek word for amber to refer the properties of attracting small objects after being rubbed. Thank you.
Hi, I'm Muhammad Afiq bin Abdul Aziz. I'm gonna continue the presentation about the background of the theory. In 1758, Charles Augustin de Coulomb, the French scientist, revealed his three initial reports of electricity and magnetism. This publication was extraordinarily necessary to the event of the idea of electromagnetism. He studied the repulsion and attraction force of charged particles by employing a measuring instrument and see that the magnitude of the electrical force between two purpose charge is directly proportional to the product of the charge and reciprocally proportional to the square of the distance between them. In his experiment, he used Coulomb torsion balance as the measuring instrument. The instrument was a rod coated with a metal coat ball hooked up to one finish, suspended by a silk thread. The ball was charged with an electricity, and a second charged ball of identical polarity was brought close to it. The two charged balls repel each other, twisting the fiber through an explicit angle that might be brought from a scale on the instrument. By knowing what proportion force it took to twist the fiber through a given angle, Coulomb was able to calculate the force between the ball and derive his inverse square quotient law. As you can see here, this is Coulomb torsion balance that Charles Augustin de Coulomb used for this experiment. And that's all from me, and my friend will continue a little bit about this background of the theory and for the conclusion. Thank you.
Hi, good evening. My name is Muhammad Afiq Zafar Ishaq. I want to explain about the Carlos Augustin de Coulomb's the histories. The Coulombs was born in Angoulême, France, on 5th June 1736, and his family moved to Paris, and he studied at the college Mazarin, and graduated in 1761. And joined the French army and engineer within the rank of a lieutenant. Okay, next, he discovered initial essential degree inverse relationship of the force between electrical charge and therefore the square of each distance, so as a similar relationship between a magnetic pole. At the moment, this relationship was named after him, Coulomb's Law. He did in Paris on 23 August 1806 at the age of 17. Coulomb gave as a founder within the field of geotechnical engineering of his contribution towards style. His name is one among the 72 names inscribed on the Eiffel Tower. For the conclusion, in the conclusion, we can conclude the object can gain or lose electric charge. The net charge is also sometimes called excess charge between a charge object has an excess of either positive or negative charge. Then a tiny imbalance in either positive or negative charge on a object is the cause of a static electricity. And lastly, the electrostatic force described by Coulomb's law. Okay, thank you. That's all.